A very good morning to all of you present here today. Guten Tag, bonjour, ni hao, namaste, wherever you are, my friends and colleagues. It is an absolute honor to be presenting at the annual Publishing Conference 2020. And before I dive straight into the topic today, let me give you a quick introduction about myself. I am Dr. Prathik Roy, and I'm the product head for nanoscience and technology at Springer Nature. I'm based out of New York City, and I work for the database group. What I'll be talking to you today is on the importance of data and the business of data. I hope that piques your curiosity. So let's dive in a little in depth into what is it that I'll be talking to you on. So I'll start off with the tsunami of information that has been gathered over the last decade, 2 decades or so, especially with the rising curve when it comes to the number of publications and patents around the world. And to sort through or dig through that data using what we call as databases, which have been around for quite a long time, but in its modern avatar, using machine learning and artificial intelligence techniques. How is it that we're sifting through the information to get the most desired data, the most useful data for a particular researcher? But therein lies the opportunity. The crux of my topic today is not so much about databases, but it's about monetizing the data itself. And is there a business opportunity outside of the databases using data? And that is the focal point of my talk today. That is monetizing the data and not the solution. Now, with the tsunami of information that has come in over the last 2 decades, as I mentioned, let me give you a more recent example. So, for instance, take the COVID-19 situation that we find ourselves in. There have been about 4,000 odd papers in the last week alone, and it's almost impossible to sift through this entire set of information and take out any meaningful data from it. There have been an army of scientists, software developers, journal publishers who are trying to gather information and get the most important data sets applicable and useful from the papers and patents that have come out over the last few months. Now, large technology companies as well as publishers are racing to create a collection of information from papers which could help us end this pandemic. And we are scrambling to build data mining and search tools that can help researchers to quickly find the information they seek. What does that mean? It means that the urgency is growing, and it is critical for us to find the most important information from within that data set. And therein comes the advantage of using databases. I mean, since January alone, there's been over 23,000 papers on the topic of COVID-19, and this has been doubling every 20 days or so. So among the biggest or largest explosions of scientific literature ever seen by humankind. And given the volume, the sheer volume of information that's coming in, it's very difficult to actually make sense of the information and get the best out of it. And therein lies the advantages of using databases, as I mentioned, or search tools. Some of these databases tend to be very popular, and scientists are already aware of them. Some of them are new, utilizing machine learning and artificial intelligence techniques. But still, a lot of these databases tend to be difficult to navigate. The user experience or user interface might be, or rather might not be, quite easy to go through to find the information that you're seeking. So with researchers, it's quite difficult, since they are reticent to change, to ask them to change the way they are trying to sort through this information without going through publication lists or going directly to the publisher's site and then identifying the information by going through every single paper and find something meaningful out of it, and asking them to change their habits and try and use tools such as databases or search tools. Because They might be able to use these tools in identifying the information that would be most helpful to them. And I've been a researcher myself. It's very difficult to get a researcher or scientist to change their habits and adapt to new tools. Not that I'm saying that it's not possible, but it's just that we tend to be quite reticent to change. It's almost as if we walk into a hospital and ask the surgeon to change the scalpel right before their operation. They're unlikely to do so. So, is there more that we can do outside of databases? But before we do, let me show you something interesting. Now, I tried to find, or rather calculate, the amount of time a researcher spends every single day searching for information. Now, usually, a researcher searches for information for about 20 minutes per day. And if you take it this as the starting point of a calculation that is 20 minutes per day, and you multiply that by the number of working days per year, which is around 250, you get about 83 hours per year that's spent by every researcher around the world searching for information. Now, there are about 8 million researchers around the world. And if each of them were to be searching for 20 minutes per day, they would spend about 66 odd billion hours trying to go through this information and then make something meaningful out of it, or rather take something meaningful out of it. Which is why databases have been very popular. Some of these databases have existed for decades, some even centuries. Springer Materials, for instance, were a database in its book form back when Einstein was using it. And then, of course, in its modern avatar, we have the electronic format databases wherein Web of Science, Scopus, Google Scholar covers all of these different fields such as physics, chemistry, engineering, biology, and medicine. And something such as SciFinder or Reaxis focuses on chemistry, or PubMed, which is biology and medicine, or Novel, which is engineering, or for that matter, Nano, which I head, which deals with nanoscience and technology, which is a combination of all of these different fields being a multidisciplinary science. So databases have traditionally tried to cover these massive fields and help researchers identify, sort through this information, and get the most relevant data points out of it. Now, databases have been quite popular for publishing companies, and several of the publishers have made such databases, which is based on the pull model of information. So the advantages of databases tend to be very good. So for instance, a customer or an organization which is mainly academia tends to pull the information that's only required, wherein this data also tends to be always updated because it's being updated from the publisher's side or whoever it is that has created the database. And hence, the customer always ends up finding the most relevant and latest information out of these databases. That said, there are some disadvantages of the database model. That is, it could have, or it could be a performance bottleneck on the customer side, wherein the customer might be pressed for resources, might not be able to purchase an expensive database, or even if they do end up purchasing it, there could be other factors such as the database might not be available to them outside of their IP address, campuses, and so on. And even if they do have offline or federated access, there might be other issues wherein the internet is not stable enough for them to access the information that they require. It's also technically challenging to implement, both on the customer side as well as the organization that's building the database, when it takes a lot of sophistication, resources, time, and money to build the database, as well as resources, time, and money invested in purchasing the database on the customer side. Therein lies the other problem that it can be expensive. So the costs associated with building the database as well as purchasing the database. There couldn't be licensing issues, wherein if it's a database that sources third-party information, the information might disappear later on. And of course, there are limited use cases where most of these databases concentrates on a very specific field. So the database model, or the traditional way of doing databases, has several advantages and of course, several disadvantages, which got me thinking that is there an opportunity out there of focusing only on the data instead of building a tool, a solution for researchers to sift through the data from within the database? What does that mean? So, outside of the database model, you could perhaps think of a push model of data delivery, wherein you're only sending out the information that the customer requires. Now, you could argue that's exactly what a database does, but the point of a database is to have all the information in the relevant field in the platform, and then the customer sorts through that set of information and then finds the most relevant information from within that. However, a data delivery model could be even more specific. So, for example, like I said, uh, talking about COVID 19 papers might exist in a biological database or could have some peripheral area, say in nanoscience and technology, where you might be using nanomedicines to treat COVID 19. So, perhaps it could be available on a product such as Nano. But the data delivery model, you could be, or rather, with the data delivery model, you could be even more specific. So you could focus on sending just the COVID 19 papers instead of sending papers in the entire field of biomedicine, or having a database which deals with biomedicine and could have papers outside of the COVID 19 periphery. So, this is one of the advantages of the data delivery model. You could also send a large batch of articles. You could process a large batch. And of course, sending specific sets of articles or patterns would be insignificant when it comes to running costs in comparison to running a database wherein you need to have this constantly running on the cloud and the information needs to be pulled in and out. So there could be performance bottlenecks on that side as well when it comes to databases, um, unless the physical servers are moved to a cloud-based server, for instance. Now, with me outlining a lot of advantages of this different model of sending data out, and please bear with me for another minute as when I try and explain as to where it is that I'm going with in this data delivery model, there are some disadvantages to it as well. So you might end up, of course, sending more than that's required by the customer. What does that mean? You could send COVID 19 papers, so that's very specific, but perhaps the customer only wants COVID 19 papers from 2020 and not all of the papers that might have been published related to coronaviruses from the early 2000s. So there could be some bottlenecks because you are technically sending all COVID related papers or coronavirus related papers. That said, of course, you could still be specific, but that's the disadvantage of the data delivery model because you are focusing on a keyword and then sending the information in to the customer. Of course, you also need to agree with the customer for updates where the database is updated on the organization side, which is building the database. In this case, the customer always needs to reach out to the organization to say, hey, send me this fresh batch of papers now because I need to be updated on this specific topic. So along with the advantages of the data delivery model, I think it's important for us to also understand that there are some cons to it. But why is this alternate model of data delivery, or how is it that we can succeed in this alternate model of data delivery? Where is it that I'm going with this? Now, traditional databases have spent a lot of resources that has invested time and money on data mining, building tools that can filter and sort through information, and then create solutions that only solve singular use cases. So, why exactly should an organization invest their time and money in purchasing a database that only solves one problem or addresses only one use case? Now, with current market dynamics and library budgets shrinking every year, we as publishers are trying to look at different business models. Now, there could be an opportunity here where instead of building expensive tools or expensive products wherein we make these databases, we could offer a focused solution by just providing this raw data. And then, if required, enrich this by creating value based on the requirements of the organization which decides to purchase this data. So, as I mentioned in one of my examples, you could focus, since you are the publisher, you are sitting on this treasure trove of information in the area that you excel in. Just focus on that particular area and then send the data in from there. So, the approach to selling this information should, of course, be data driven. So, if the customer wants the data to be enriched, then you focus on enriching the data instead of creating the solution before understanding the problem that is faced by the organization. What do I mean by that? I mean, if the customer, again, focusing on the COVID papers, wants only the raw data related to COVID-19, then you give them the raw data. So perhaps they want to find out how a specific material interacts with the COVID-19 virus and if it can diagnose it as well as perhaps destroy it, thereby curing the COVID-19 or curing the patient from COVID-19. Now, the customer wants some enriched content wherein, in addition to the data points from papers that scientists have studied and then created, they also want enriched content when there might be a specific drug out there which helps in curing the COVID-19 virus, and the customer wants to find out all the information about this drug, wherein if there have been clinical trials that have been run. So that the way you can enrich the content of the data that you're selling by acquiring further information. Again, you could, of course, price the data and the model, the business model around the fact that if you provide raw data, then you charge X amount of money. If you enrich the content, then you add Y amount of money on top of the X. In addition to all of this is also the fact that metadata should not be in the meta state. Again, what does that mean? That you don't want to be providing metadata that's vague. And while the data is raw and hence untouched, you could provide metadata, meta information in addition to it, but only if the customer asks, as I stated in my previous example. So the value addition depends upon the fact that whether you want to add the value, but I say wait for the customer to tell you if they want additional value to the data that they're purchasing, and then you enrich the data. If you must build a solution, then custom build it based on the use case of the customer. So wherein a database focuses only on a singular use case, as I mentioned, or tries to solve only one problem, you can focus on sending the data out. And if the customer wants a use case to be solved, then you can then build a small solution around it. And then it still focuses on a singular use case, but it won't be nearly as expensive as creating an entire database on an entire set of topics. So the other point of this technique of pushing the data out or the data delivery model is that your data as a publisher is unique to you, and hence you can tailor solutions for the customer that nobody else can, and hence it allows you to price your data the way you want to. Now, this is basically what I've been getting at all of this while. The data delivery model allows you to create this business model which publishers, in my opinion, have not really focused or concentrated on. We are sitting on massive amounts of information and really strong, good, high value data sets. So there is an opportunity here that instead of building databases, we could build a data marketplace wherein this marketplace has different subsets of data, and then it's up to the customer to purchase whatever data in whatever topic they want, raw data from within this marketplace. So if you're focusing on publishing articles that focus on biomedicine, if another publisher focuses on journals that publishes research on semiconductors, or another one on, say, pharmaceuticals or nuclear technology, or any one of these different fields, you could have a data marketplace that caters to all of these different topics by only extracting and then curating the data from each of these topics. And this is an advantage because the data is only growing every single day. So you could keep adding more sets of data within that, and then you could keep selling the data at different periods of time. There is, of course, also another advantage to this technique that you could digitize your old information that has already been published, and then you could sell that data as well within this data marketplace. You could, of course, enhance this, as I was talking about earlier, with the power of analytics by licensing out certain sets of information, and then you could add the value by the example that I gave earlier, where if the customer wants only information related to materials that treat COVID-19 and you have that information in your data set, then you could potentially also ask the customer if they're interested in finding out if the material has been used elsewhere or if there's been a drug that's been used to treat the COVID-19 virus, and hence clinical trial information in addition to it. So that's the value add that you could provide. Of course, you could also provide trust and security by blockchain technology. And of course, most importantly, because the data is raw and has not been touched at all, the customer can believe that this data is trustworthy and is highly reproducible when somebody has not extracted this information. Of course, you extract this information and then sell the data set, but not extracted this information and then used it elsewhere and is then selling the solution when it's already been touched upon based on whatever solution that the user is then selling to the customer. This also helps the publisher to come up with unique use cases or cater to use cases of the customer and more than one use case. So you could allow the customer to then use their APIs or artificial intelligence or machine learning techniques for them to build their own solutions based on the data that you've sold them. Of course, going back to point number two, you can, of course, license this data out instead of selling it to them outright. So there are a lot of advantages to this data marketplace model instead of the database model. And of course, with us coming to the marketplace, it allows you to cater to many different problems and not solve one different problem. So you don't need to have one solution, you could have multiple solutions based on the problem that the customer has. And this ebb and flow, demand and supply can help generate additional revenue and recurring revenue because you're constantly having new data, fresh data coming in, and then it allows you to then sell that data again to the customer. So think of this as a loop, a circle, where you will have the data, you have analytics, trust and security of the data, address various use cases, and all of this sitting in this data marketplace. So ultimately, what we could create is an Amazon or a Netflix model of databases, or I beg your pardon, a Netflix model or an Amazon model of selling data or different sets of data. The possibilities of such a business model where we could have a data marketplace instead of a database is endless, when you could build a bridge across multiple stakeholders by providing this raw data and then, if required, filter it for relevance or leave it completely up to the customer, where you could go from the raw data to the use case of the customer, and then the customer could either filter for relevance, extract key concepts out of it, and then add value or create value for themselves But if the customer wants, you could tailor certain mini solutions when you could go from the raw data, filter for relevance based on what the customer wants, gather key concepts from the data, and then add value and then address the use case of the customer. But the questions that we need to ask ourselves before we build these many solutions is that where is it that we're creating this value, the data value? What features are required for building that value from the data? How can we put all of this into a framework? And then how and why will it benefit the customer? So these are all standing questions before you go on to the path of either selling the data or creating a mini solution for the use case of the customer. At the end of the day, though, you do that by creating lexical facts. You extract the lexical facts, you extract the numerical facts, and then either you could sell these as individual entities or you could combine this to create the knowledge that the customer wants. And all of this can be done by just the content that you have, just the content that you can filter, and only the concepts that you know and content enrichments that you can produce. And at the end of the day, data that only you own and can license out to the user. So all of these amazing things can be done with the help of a data marketplace instead of building a complicated, sophisticated database solution. So I'd like to end this talk by emphasizing on the point that I mentioned earlier that there are about 8 million researchers out there. And when we build solutions, we are usually catering and then selling it to these 8 million researchers. But real revenue can come in because or from the fact that there are about 7 billion people on this planet. And when you are selling data, you are opening up new avenues, new marketplaces that have not existed before. Because currently you're only selling to either academia or certain chosen corporate customers. But there are other companies out there that could use this data in ways that you might never have thought of. So when you have this database, or rather, I keep saying database, the data marketplace model instead of databases, you could then have the flexibility of selling the data in whatever manner you choose, and it's up to the customer to use the data in whatever manner they would like to use it. And thereby, there is 100% more opportunity for you as a publisher, or should I say 7 billion more opportunities than 8 million opportunities at the current moment. I hope that this topic was interesting to you. If you do have any questions, then I would love to take them now. Thank you and have a great day.